Is there how do I advance that? Just with the keyboard.
Just use it back and forth.
Yeah.
Okay, it is 9 o'clock. Welcome to this morning session on production system design. The first speaker is Iris Tomline, about collaborative TAKT time planning of non-project work.
Thank you so much, Frodo. Good morning, everyone. Thank you for coming to the session. I must say, though, I actually don't have anything new per se to tell you, but the purpose of this paper is really to help define some terminology, articulate the objectives and the methods that we have used in TAKT time planning, and describe the details of the process steps. And the goal of doing that is really to try to be as explicit as I can, so that when other people describe TAKT time planning, I hope that they will also take the same care and effort to describe what they're doing, so we can compare what's going on, because our community in the last 2-3 years has been talking about TAKT time planning, and TAKT time planning is evolving in different contexts, in different situations, in quite different ways, and I think there's value to understanding what the differences are. So to the beginnings, TAKT is essentially the word for beat in German. We can say TAKT time, or my German colleagues will correct me and say, well, you only need to say TAKT. That's enough. So it's the unit of time within which a product must be produced, what we call the supply rate, in order to match the rate at which that product is needed, what we call the demand rate. So it is a design parameter that we can use in production settings, and we specifically use it in what we call work structuring. So what is work structuring then? It's a term that Glenn and I and others have been using for quite some time. It's sort of the counterpart of developing a work breakdown structure, but work breakdown structures in traditional project management have a lot of baggage associated with them, and we're trying to not have that baggage. So we want to revisit from scratch. If you have a project and you're going to break it down in smaller pieces that are manageable, what questions do you need to answer so that you can actually go into production? That's what work structuring is. So the questions are, in what units of work will work be assigned to the production units, to the construction trades? How will the chunks be sequenced? How will work be released from one production unit to the next? Will consecutive production units execute work in a continuous flow process, or will their work be decoupled? Where will the decoupling buffers be, and how should they be sized? And last, when will the different work chunks be done? So with that in mind, for work structuring, then the question is, well, what objectives are we trying to achieve when we are using TAKT time planning? And specifically what we're interested here is to have trades work in the way that they prefer to work, to the extent that that's possible, as opposed to the traditional project management way where a general contractor might make a schedule and then say, here, go do the work according to my schedule, make it work, make your methods work with my schedule, as opposed to I will adjust my schedule to your methods. We want to aim for constant crew sizes and continuous workflow. We want to avoid trade stacking. We want to have only one trade per zone for each TAKT. We want to use timely TAKT handoffs, and then we want to balance the whole while pushing for speed. So the process steps that we're using need to be situated in the context of our planning system. So if you're familiar with the levels of the last planning system, master schedule, phase scheduling, look ahead, and weekly work planning, we situate TAKT planning as input to what is called a phase schedule. So the notion is, when you develop a phase schedule, imagine that there's several phase schedules feasible within the constraints of your master schedule. And if there are multiple phase schedules feasible, then how are you going to judge which one is the better phase schedule? And that's where we have our objectives for TAKT planning, so we can begin to discriminate. So within the phase, before we get to phase scheduling, then we need to ask these questions of work structuring with our TAKT time objectives. And the process for doing that is described on the right-hand side. It's the how. We want to collect data, define the zones and the TAKT times, create a flow, balance the system, then pull plan, reach team agreement among all the participants involved that the schedule that they have is a good one, and then fine-tune the system. So what throttles do we have? What are the variables, what are the parameters that we can be playing with in coming up with that phase schedule, with understanding how we can TAKT our work? So first of all, we have the product and the component characteristics, of course, what traditionally shown in a BIM or in drawings and specifications. We have the worker and the crew trade skills, which of course will vary from worker to worker. We have alternative breakdowns of the scope of work. Whether a scope of work is going to be done by one trade or by another trade is something that is to be decided. Oftentimes it's covered perhaps by union jurisdictions, but it is something you can play on. We need to consider alternative means and methods that are available within each trade, and then also we need to decide on, we need to have control over the number of trade resources that can be assigned, because that decides on speed. So a crucial concept in the way we have been doing TAKT planning is what I've called work density. And work density is defined as a unit of time per unit of area for a specific trade. And the definition is, given a certain work area, work density describes how much time the trade will require to do their work in that area based on these different throttles that we have: the product design, the scope of work for a given task in the schedule, depending on how the task is broken down temporally to be performed and interwoven with other tasks of other trades, the means and methods that the contractor will use, and then also, of course, while accounting for crew capabilities and size. And so work density is really the crucial parameter. What we want to identify is we want to identify zones and times so that each trade would spend the TAKT time in each zone in order to get their work done, right? That's really what we're after in the TAKT time search, shall I say. So the process that we followed then, it's still quite a bit of trial and error involved, but I'll tell you what we know so far. So we collect the data, so we start with design, drawing, specifications, building information models if they're available. And we sit down with each of the trades and we ask them to do what's called color ups. So in this case, in the lower right-hand side, we've asked the mechanical contractor to think through the sequencing of the work that they have for the specific floor plan and to break their work down in 2-day increments. And so they started coloring the drawing and said, well, in the first 2 days of work with the crew that they have in mind and the means and methods that they have in mind to do the work that is shown, they would do all the work that's in orange. The next 2 days, they would do all the work that's in blue, and the next 2 days, they would do all the work that's in green. Right? So that's kind of fundamental input information that's not readily available in the way we do construction management today. So as part of collecting data, then you see on the left-hand side here, we collect these color-ups for each of the different trades, and you can see in the upper left is actually the mechanical ductwork. What I showed you before is the hydronic piping for the mechanical work. In the lower left, you see what the electrician showed us as their color-up, so you can get a flavor that the color-ups vary quite a bit from trade to trade, and of course, the trade-specific drawings, for that matter, are also very different from trade to trade. So in addition to the color-ups, we need to understand the flexibility that the trades have in terms of flow. So the ductwork will start in one location and move as the arrows indicate. The drywall installer might move in another location, electrical in another location. And then from that, we infer what we call density. So we superimpose a grid over the color-up, and we can then show in darker colors if more time needs to be spent in those areas, and in lighter colors if less time is to be spent in those areas, based on what we know from the color-ups. That gets put together, and this is where the trial and error process still is significant. On the left-hand side, what we then do is we develop different zones, and we superimpose these zones on each of these work density maps. And from that, we can infer the histograms that then indicate how much time each trade is going to spend in each of the zones as defined. And probably in the first iteration, you find that there's a lot of variation, so you may have to go back and adjust some of the throttles that you have in the system. You can adjust the zones, you can adjust the speed, maybe you can adjust the work methods, you name it. That's what the throttles are for. And after some iteration, then you come up with a TAKT schedule. With the TAKT defined, we can then go back to the flow that the contractors wanted to follow and the sequence in which they wanted to do the work. And there too, that's generally up for some negotiation at least. There's usually some flexibility. And with all that then, we put it together in a plan that we propose to the contractors to follow. And then of course there needs to be a lot of discussion, as in what did you reflect in the plan, and can we do it, can we not do it. So the fourth step in the process is to develop a pull plan with the team, but based on the information that they've received from us doing the TAKT time analysis and the zones and the TAKT that we have proposed. And then putting it all together, what you see in the upper row then is 14 TAKT beats of 2 days each. And in the lower right side, you see what this looks like in a line of balance. What's important here is to know that we are working with very kind of uneven types of work, right? It's non-repetitive work, and therefore the line of balance looks very haphazard, shall I say, even though from individual contractors' perspective, the flow is very smooth, or at least as smooth as we could get it. So back to the purpose of this paper then, we really wanted to provide a basis for comparing and contrasting TAKT time planning approaches. I'm glad to see some of my Karlsruhe Institute of Technology colleagues have arrived. We've actually been talking about comparing some of the TAKT time planning work that they have been doing. And so hopefully this paper will help establish a common ground, a common language to compare methods. Thank you.